So this is one of my main pieces of equipment that I use here in the lab, and it's my HP 8350B sweep oscillator, and this is just the mainframe here, and here we have a plug-in, because you can get different plugins for this for different frequency ranges, and you know, to make it a little bit more versatile. Now this plug-in here is my latest eBay purchase, and believe it or not, I've had a search set up for the past 2 years trying to find one of these at a reasonable price, because this plug-in tends to go for over $1,000. They're quite rare to find here in the UK, and if you do normally find them, sellers are asking a lot of money for them, and even, you know, up to about £800 as a spares repairs item, completely untested. So they're extremely rare and extremely expensive when you do find them. Now this particular plugin, I was quite lucky. It came up on the eBay search last week, and I managed to get this for £125. It was sold as a unknown item. The seller didn't normally sell things like this, and normally sells surplus computer equipment that you know, you get from people upgrading in offices and things like that. But he had this, and he had it at a starting price of £99, and of course he had there a disclaimer saying he didn't know if it worked or not, he wasn't able to switch it on, etc. Now there was no bids on this right up until the auction finish. About 30 seconds before the auction finished, somebody put their first bid in, and I put a bid in of I think it was about £200 in the last 8 seconds to try and snipe this, and there was a second bidder with me, and I think in the end I got it for about £125. So he managed to put a second bid in as I put my bid in. But I've won it, and I'm really pleased with this. I've been after one for so long, because the frequency range on this particular plugin goes from 1 megahertz right up to 20 gigahertz. So I've got the full band to play with, and I'm sure I'm going to do a lot more things with this than I could do in the past. So for instance, at the side of it here, I've got my main plugin that I've been using now since I picked up this mainframe, and this one goes from 1 megahertz all the way up to 2.4 gigahertz. It actually creeps a little bit beyond that to about 2.6 gigahertz, and it's just that little bit of a cut-off where I don't actually want it, so I can't see the full span when I'm testing antennas at 2.4 gigahertz. I've got that little bit of a cut-off. So I was looking for one of these for that reason, because I can do a sweep now from 2 gigahertz up to 3 gigahertz, and we'll get a nice image of my antenna in the middle of that sweep. So it gives me a good, a better picture than previously that I could get with my old plugin. Now I have got my slightly older sweep oscillator here. It's the HP 8620A. It's the previous generation to that one, and I have got various plugins for this one, so I was able to do slightly different tests. You know, I could actually span the frequency, especially to 5.8 gigahertz, because I have got this plugin here that's in the sweep oscillator, and this is a 3.6 to 8.5 gigahertz plugin, and I have got the adapter to actually adapt these older plugins to fit into the slightly more modern mainframe here. But unfortunately, when you do that, you do lose some of the functionality of this more modern mainframe, because you don't get the digital readouts for the power levels, for instance. It's a little bit of a guess where the power level is, and you've got to use your network analyzer to measure the power before you do say a measurement on the VSWR. So it's a little bit of a faff. It doesn't really work that great, but I've always been able to get away with it by using the plugin. So I'm really pleased with this purchase, but you may be able to spot the one problem that I've got with this particular plugin. There's no output, there's no RF output on the front here, and the reason for that is because it's on the back. So this tells me that this is probably come from a automated setup, probably in a rack mounted situation. It probably just did the one job over and over again, the one measurement in the factory, doing the one test over and over again. So they wanted the outputs to be on the back of this to get it all automated. So what I've got to do is connect up the front here. So I've got this output, the RF output, which is what I use mostly here on the front, just for ease of use here on the bench. And it was an option to have the outputs on the back, but sometimes you would get the outputs on the back and they'd leave the outputs on the front but just disconnect them. But here they're completely blocked off, so they were probably purchased for a specific purpose in a automated test setup. So what I'll do then, I'll bring this out onto the bench and we'll take a look and we'll see how difficult it will be to do that modification. I have got some of these RF N-type plugs because I've got a plug-in that doesn't work, and I've already scrapped it for a few of the parts. So I have got one of these already. It's just whether I've got enough of the rigid coax to run it from the coupler where it will be coupled from, instead of going all the way to the back, all the way to the front. So we'll have to see what we've got inside there to actually play with, whether we can do it with the parts that are already inside or not, I don't know. So here's a shot of them both side by side, just for comparison. My new one is here and the 2.4 gigahertz one is here. Now the new one does look extremely clean. It doesn't look like it's been taken apart at any time during its life. The screws are all still nice and shiny, where if you have a look at my 2.4 gigahertz one here, you can see that the calibration stickers have been scraped away. You can tell by looking at these Phillips head screws here quite closely that they've been rounded off a little bit by opening the cage up here from time to time. So it's in extremely good condition, this one. And all the plugins for this particular range, they're all virtually the same to look at. Obviously they've all got to fit into this form factor cage, but HP have made as much as it possibly can modular, so it doesn't have to have specialist parts made just for the frame itself for each individual plugin. So they've tried to keep the costs down, although I'm not sure about the price of these back in the 1980s when these were produced, but they would have been extremely expensive, and as I say, they're still extremely expensive today. So this is the part that we're most interested in the plugin then, so we can reroute the RF out to the front of the plugin itself. And this is the directional coupler, and to be quite honest with you, with this being 1 megahertz up to 20 gigahertz, this is an extremely wideband coupler, and if you put this on eBay just on its own, you'd probably easily sell this for £100, just with it being so wideband and just selling that coupler on its own. So that's why a lot of people do strip these down for parts and sell them separately. But I've been lucky with this one, and I've been patient, waiting almost 2 years to pick one of these up. But this is a directional coupler. You've got the RF coming in, and then the RF out here. This is the final RF frequency that goes out to the end connector, and you've got a little voltage diode detector here on the coupled port. So it's very similar to what you would use to test VSWR, and that's why you could probably sell this on its own, no problem. So the one thing with these plugins is that they're all laid out in a very similar way. There's not much difference between them. Obviously they've got different oscillators in there for different frequencies, and some slightly different circuitry in some, but the main layout of these are all the same. So this is the RF out here, and this is the rigid coax. So all you've got to do is follow that rigid coax all the way to the end, because there'll be nothing else in line with this. This will go straight out to the end connector and the RF out. So hopefully I may be able to modify this rigid coax here so we can replumb this to go to the front, because we've got not as far a distance to go from here to the front of the plug-in here. So hopefully I can reuse this coax, because I don't want to use any of my semi-rigid coax or normal traditional coax, because this plug-in goes up to 20 gigahertz, I know the semi-rigid coax that I've got does not, and I have got some of that nice rigid coax that I used in a previous video to build those jigs. But I really want to keep it the same because I know this is going to be rated up to 20 gigahertz, so hopefully I'll be able to reuse this. So just under these silicone wires here is where the coax bends round and feeds back to the back of the plug-in. We've got this ribbon cable looping over the top of it as well, so it's really packed in tight down here, but I'm hoping I'll be able to lift it out without removing too many of these components, so it goes all the way along here down the back and then down and feeds out to the back of the plug-in around the back here. So I think I should be able to reuse quite a lot of this coax, and as I say, I don't want to go removing any of these components, but possibly if I cut it around here, then I'll get quite a long piece that I can modify to feed the front, so hopefully I can take it out without removing any of these components. So here's a look at the back then, and I've taken this faceplate off here that's just held on with 4 Phillips head screws, so I removed that. Now what we've got here is a second plate here that's held in with this Phillips head screw, but I don't think removing that screw is going to help us to get into there to disconnect the output from this end connector here, because it's rigid coax, so if I remove this it's just going to make it wobble because there's no giving that rigid coax. I'm not going to be able to pull it out in any kind of way. So what I'm going to do is there's Phillips head screws around the case itself, so I'm going to remove these from the end here, and then what I'm hoping is I can pull this fixture out just a little bit because there's some give in the flat flex cables etc and all the connectors, so I can get in there and then get my little spanner and remove the nut that's connected to this end connector, and then hopefully we can loosen the nut on the other end and we can somehow wiggle that rigid coax out of there. And here's the back plate, and it says option it says 004. Option 4 is the output at the back for the RF output etc. So all the outputs were on the back and we've got none of the outputs on the front there. And as I said, this was probably in a test setup automation, and even the controls on the front of this plug-in are really in good condition because they probably controlled all of this via the GPIB connection, and you know, it was controlled on a separate terminal, so this really is in good condition, and it probably got serviced on an annual basis as well. So I've just removed the Phillips head screw, so hopefully now this should just slide away, and we've just got to be careful with the ribbon connectors connecting to these plugs here on the side. So very gently. And then we can pull it away, so we can get in there now with the spanner and remove that nut there for the it's basically an SMA connector going to this N-type plug, and then I can do the same on the divider here, the sorry, not the divider, the coupler, and then this should all be loose, so hopefully we can find some way to wiggle that rigid coax out of there so we can use it again to do the connection at the front. And with the HP test gear, they do design it in such a way that you're able to get in there and service, and the service manual is available for download from the Keysight website, but I haven't bothered because you know, I've taken one of the older generations to pieces before, and they are very similar. I mean, this cover on the back here, the part of the cage that holds all the gubbins together, if you like, is virtually the same as on the older ones. So everything, you know, is set out in a particular order, and it is made to be serviced on a regular basis, especially if it's in a you know, a setup situation in a factory or in a laboratory science setup, because they do have them calibrated and serviced probably on a yearly basis, but for an amateur, you know, I can't afford to have this serviced and calibrated every year. But they're made so well that they hold the calibration in a roundabout area anyway. I don't need it to be that precise, but they are a really well made piece of kit. You can see why they are so expensive. Even 10-15 years later, they still hold the value well, especially for a good one. So having looked at this for a few minutes to try and work out how to get this rigid coax out of here, you can see here if I wiggle it, it has a bit of free movement in this area here, but because we've got that slight bend at the end there, it's like a hook catching on these components here. So what I think I'm going to do is cut that so it's straight in that area there, and then if I flip this onto its side, if I remove this coupler, disconnect the detector here and this rigid coax here, and completely remove that coupler out of there and this plate as well, I think I should be able to wiggle it and pull it in this direction towards me, and I should be able to get it out that way without disturbing anything else too much. So I think that's probably the best way forward to get this rigid coax out so we can use it again at the front. So again, if I cut it off here, and then we've got that free movement there, I should be able to pull it slightly this way and kind of wiggle it out if you like. So I just use my side cutters to snip the end of that rigid coax off there, and people have asked me about these side cutters before, where have I got them from, and these are actually Warhammer side cutters. I was introduced to these by my middle son. He's a bit of a Warhammer fan, and he had a pair of these, and I borrowed them, and I was really impressed how you know, sharp they were and precise. So I ended up getting myself a couple of pairs, and these have been my go-to snips now for probably getting on for 4 years. They really are good, and they last quite a length of time as well. You don't get that you know, kind of gnarling here when you try to snip something like this, which is a little bit tougher than what they're designed to actually be used for. But they really are good quality snips, well worth the money. So the trick with doing something like this is not to rush it. Don't put any unnecessary force on the coax or any of the other components, because there are some fragile components here. But as you can see here, I've had to remove a few more components to get this out, but I basically kept everything in situ. I've had to loosen off some of the coaxes here, because even though these are rigid coaxes, there's still a little bit of flexibility in them. I've had to remove these two plugs here, and again this rigid coax from here, because it kind of goes over the top of the one that I wanted to remove, so it was blocking it a little bit. But now I'm able to wiggle this out, no problem at all, and I can just put all those connectors back as soon as I get this coax out. But again, you've got to be really careful not to damage anything. And there we go, we've now got a nice piece of coax that we can hopefully use to put the end connection on at the front there for the RF output. So here's a look at the directional coupler then, because it's so broadband. It goes from 1.7 gigahertz up to 20 gigahertz, and you know, I paid £125 for the plug-in, but if the plug-in didn't work, I could probably put this one component on eBay for, you know, say something like a buy it now for £100, and it would eventually sell. I mean, it's not a hot product like a iPhone for instance, but with this being so broadband, it probably would sell for around £100 quite easily. So at the moment then, I'm trying to work out if I can use this rigid coax that fed the back connection there with you know, the least amount of bending possible, because it's a special tool to bend this stuff, and if I bend it too much, it might look okay from the outside, but you can end up cracking the dielectric on the inside. So I'm just trying to plan it out here to route it underneath the circuit board that's there to come out and connect to the front there. But I think I'm going to be able to bend this in such a way that I can use this. But if I can't, you're probably wondering why I don't use this stuff. And this stuff is not rated up to 20 gigahertz, which this plugin can go up to. I'll probably get away with this fine for the 5.8 gigahertz. But again, I don't really want to use this. And as a other option, I could use this rigid stuff that you've seen in the previous couple of videos. I could make, you know, the connectors fit this and route this from the coupler here to the connection at the front. And you know, if push comes to shove, I probably will end up using this stuff. So I've been working on this for the best part of an hour. I've been so patient with this, you would not believe, because I didn't want to put a crack into it. Now, I did test a shorter piece before I did this, and I cracked it here, and then I tried flooding it with solder to repair it, but it's just messy. So I started again, but this time really taking my time and bending it in these areas here. As you can see the shape, slight bend here in the middle, but not too much. And I also found that adding a little bit of heat as well helped to put that curve bend in there. So I've now got it laid quite flat and as straight from point A to point B as I can get it, and it does fit in the plug-in now, so I'm quite happy with this. I really did want to use this coax because at the end of the day it's rated up to the 20 gigahertz, or HP would not have included it. You know, my fallback would have been to use this coax that is apparently rated to 18 gigahertz and just try and find the appropriate connectors to actually solder this onto. But I'm quite happy how this has turned out now. So I'm going to put the end connector at the front of the plug-in, and then you know, just tighten this up just so I can put a mark where to cut this off to add to the coupler. So I'm fitting the end connector on the front panel here, and to save a little bit of time so I don't have to remove this front panel, I'm just taking my time again, just using these pair of tweezers just to get that locking nut in place, and then get in there with some needle nose pliers and give it a couple of turns at the end. I think this is going to be much quicker than trying to remove the front panel. So the coax is fitted in, and the SMA nuts are tightened up there now, so fits in quite nicely. It fits just under that circuit board there, doesn't touch it, and then it goes all the way down here and fits into that coupler there. But we'll keep an eye out for something that's a little bit straighter on eBay, but it's worked out not too bad. Just the amount of time I had to take over bending this coax, because it is extremely fragile and it was easy to crack. But at least now I've got the RF output on the front of the plug-in. So I'm just giving the output a quick test after that modification, just to double check that everything's working fine. And I've got it set to a static frequency output, not sweeping. It's set at 2.4 gigahertz, and as you can see on the display of the spectrum analyzer, it's showing 2.4 gigahertz, and it's a really nice, clean, stable signal, a lot cleaner than my other sweep oscillator, the 8620A. When you set that to a specific frequency and not sweep, it is a little bit noisier. So this is a lot better machine. I'm sure I'm going to get some more accurate measurements with this plug-in now with the mainframe itself. So again, 5.8 gigahertz, just like the 2.4 gigahertz, we've got a really nice output, really nice clean signal, so I'm really happy with that. And just to give it a test all the way up to the top, I've inputted 19.999 gigahertz, and as you can see on the spectrum analyzer, it's outputting 19.997. It's kind of fluctuating between 6 and 7, so in my lab setup here, I don't think I can ask for anything better than that, to be honest with you. I'm really pleased with this plug-in. I was really lucky to get it for the price, but patience paid off. A couple of years waiting, and I've eventually got one. So as always, I hope you enjoyed the video. Any questions or comments, please drop them below. I'll do my best to answer them, and hopefully you'll join me on the next one.